All right, welcome back. We are still doing the 7172 review. We're doing number 4, 5, 6, and 7. We are going to go ahead and get started with number 4. Number 4, we deposit $3,500 into an account for 15 years that pays 4% annual interest. We want to find the balance of the account if interest is compounded quarterly first. So here's the general formula that we're going to use. There we go. A equals lowercase a times 1 plus r over n, close the parentheses, to the nt power, where a is your starting amount, I'm going to abbreviate. R is your interest rates. R is the interest rates. N is the number of times interest is calculated. Per year. And then T is the time in years. Okay. This time it's quarterly. Quarterly means 4, 4 quarters in a dollar. So the amount that we want is $3,500 times 1 plus my rate. 4% written as a decimal is 0.04 over quarterly means 4. Now we raise that to the 4 times. Now we find the years for 15 years. There we go. Running out of room there. And when all is said and done, whenever you compute everything here, that's A equals 3,500 times 1.01 to the 60th power, which gets you an amount of $6,358.44. I think I'm going to use a different color this time. I would like to pick purple. Thank you. This time interest is compounded annually, so this time my n will be 1. Everything else stays pretty much the same. So we got 3,500 times 1 plus 0.04 over 1 to the 1 times 15th power, which is 3,500 times 1.04 to the 15th power, which gets you right around $6,303.30. Okay. Now I want to see if interest is compounded continuously. Here's where we use E. So we have A equals capital P e to the rth power, where P is your principal, R is the interest rate, and T is time. So maybe I'll just write P, your principal amounts. Okay, so here's the equation I want to use. A equals 3,500 times E. My rate is 0.04. My time is 15 years. Plug that into your calculator, and we get an answer of right around $6,377.42. And there we go. That's number 4. Here we go. Number 5. You buy a new car for $22,500. The value of the car depreciates 15% each year. Write an exponential decay model representing the car's value after t years. So, decay, we use the same kind of base equation here as growth. A times b to the x. Where in decay, b is equal to 1 minus whatever the rate is. So in this case, my b is 1 minus 0.15, which is 0.85. So that's my b. So y equals 22.5 times 0.85 to, and I'm going to say after t years. And there we go. Now, why did I choose t instead of x? Because we're finding it after t years. Find the value of the car after 5 years. This time I'm replacing t with 5, and we're pretty much done. So y equals 22.5 times 0.85 to the 5. Plug that into your calculator. You should get 9,983.37, right around there. Number 6. From 1990 to 2000, the population of California increased at a rate of 1.28%. In 1990, the population of California was 29,816,591. We want to write a growth model this time to represent California's population T years after 1990. Here, since it's growth, my B is equal to 1 plus R, but we're still going to use AB to the X. So, we got 1 plus my rate. My rate is 1.28. Written as a decimal is 0.0128. And you should get 1.0128. So the equation that I want to use, or the model rather, will be, oh boy, I don't know if I'm going to have enough room to write this. I'm going to try my best. We got 29,816,591 times 1 point. You know what? I'm going to go ahead and erase this stuff. Hopefully you've had a moment to digest it. I'm just running out of room. Thank you. Good Lord. Don't know why that's not going right to it. 0.0128 to the T. And that's the model that I want to use. 1 plus R, 1 plus 0.0128. There we go. Now we want to find the population of California in 2017. So here we want to take 2017 minus 1990 to find the number of years. That is 27. All right. So now we know T. So we're just going to plug it into the model that we already generated. 29,816,591 times 1.0128 to the 27th power. And you should get right around 42,033,707. Here we're talking about people. And there we go. Number 7. This one's kind of an interesting one because we're talking about the coronavirus, COVID-19. For number 7, they give us a graph. And on February 15th, Spain had 2 cases. On April 18th, they had 198,674, a little bit of a jump. This question is broken up into 4 parts, as you know. How many days are from February 15 to April 18? Well, here we go. We have February 15th to February 29th is 14 days. Now remember, we used February 29th because this year's a leap year. And March has 31 days. And then April so far we've only had 18 days. Because that's when our cutoff is, April 18th. So we just need to add up everything here. Add this 18, this 31, and this 14. That is 45, 55, 63 days. Man, I don't know what is up with this marker, but something's going on. Can't tell if that was mine or somebody else. Anyway, doesn't matter. Write an equation calling the growth rate b to represent this situation. Once again, a times b to the x is what we're going to use. The equation I want to use is 198,674 equals 15 times b to the 63rd power. Excuse me. Now see, I want to show my work for finding the growth rate. Here we go. First, we need to isolate that b to the 63, so I need to divide each side by 15. 674 divided by 15 is equal to 15 times b to the 63rd divided by 15. From here, we do 13,244. That's supposed to be a 4 right there. 0.93 with the 3 repeating. We want to take this to the 1 over 63rd power, and that'll get us b. Man, this is not the best pen to write with. I apologize. I'm going to try some of those again. Okay, so that's supposed to be a 4 right there, and that's supposed to be a 3. There we go. Okay, we are good. And whenever you do that, you'll definitely need a calculator, even I'm not that good in my head. You get 1.162597. I'll call it good there. I want to find the percent. That gives me my rate, so move the decimal 2 places to the right. So we got, I may have copied that down wrong. We're going to go with it, though. 16.26%. Oh, wait, no, never mind. I'm good. I misread my handwriting. I'm fine. We're good. Number D, letter D. How many cases in Spain expect on April 24th if the growth rate continues as is? And out of curiosity, do a Google search to see how close your predictions were. So real quick, we got y equals 15 times 1.162597. I'm going to use the whole thing. April 24th after 18, 19, 20, 22, 23, 24. So that means I need to add, 6 days? Which means I would need to go to the 69th power. So here, got y equals roughly 490,588 cases. And obviously, it's not April 24th yet, so we don't quite know how many there will be. Maybe our number is close. We don't know. But anyway, that is the rest of the review packet. Thank you guys for tuning in. If you got other questions, shoot one of the Algebra 2 teachers an email. Otherwise, we'll leave you to it. Catch you later.